Hello, my name is Slavo Petric. Let's look at ECSS PUS Service 5. I'll first give you a brief overview of the PUS Service 5, and then I will show you a live demo of how to send PUS 5 telemetry in the PUSopen framework. So, briefly about PUS Service 5, it's one of the 23 PUS services defined by the ECSS space standards. The PUS Service 5, or as we call it PUS 5, sends short messages announcing different events in your system to the receiving side. The service is called event reporting by the ECSS standard. You can send PUS 5 telemetry between your main satellite computer and the ground station, but also between onboard subsystems of your satellite, let's say from your scientific payload to your main computer. PUS 5 messages typically contain notifications about different events in your system, like critical level of battery, finishing of long processing, readiness to start a new task, and a different error announcements. It depends on your system and software architecture. There are 4 levels of the PUS 5 telemetry: TM 5, 1, 2, 3, and 4. Level 1 is informative event, while levels 2, 3, and 4 are low, medium, and high severity anomalies. Let's say that your payload finished processing image data and you want to notify the main onboard computer that the data is ready for downlink to the ground station. So you can send TM51 report with a custom message, let's say code 5, my data are ready, start the downlink. Another example might be when your payload hardware fails after some year in space. That happens. That is a critical situation, and indeed the ground station shall be notified immediately. So once your software detects a, let's say, failing camera or any other hardware, your system can send TM54 high severity anomaly with a custom defined message saying hardware failure detected. The ground crew then can decide what to do next. That's about it for the introduction of PUS Service 5, and now let's jump to the demo. So in this demo we'll send TM51 telemetry from the server to the client through the TCP socket. In this demo it's a TCP socket that is connecting the applications, but in your application very probably it will be like an onboard data bus, or it will be a radio between the satellite and the ground station. So let's start with the sending side. We'll start by including PUSopen.h, which is the only header file that you need to include from the PUSopen framework. It internally includes all other necessary header files, so only include PUSopen.h. So we'll define the main function, and we'll define some event data that we'll send together with the TM51 telemetry. The size of the data is actually defined for each TM51 telemetry report in the XML configuration file. So here we will define a transmission buffer and the server. We will initiate the server. As I said, in this example it's a TCP socket, but in your application it will probably be a data bus between the subsystems on board, or then the radio between the satellite and the ground station. Now this is the important stuff. We need to initialize the PUSopen stack. So we need to initialize it in the layers, and the first layer that we will initialize, the lowest one, is FES, which is the encoding layer for byte stream. Then we will initialize the packet layer and the PUS1. Then we will send the TM51 telemetry, and we will define the event ID, then the event data, and the destination API ID. So it's just one function that you need to call in order to send TM51 telemetry. We'll create a frame out of that, so that will give us, out of the TM51, this function here will create a byte stream that we can feed either into the radio or then into the data bus, sending data over to the to other system on board. And then we will call server send, which will send the data over to the client side in our demo. And let me just finish this main function here, and that's all for the sending side. So once again, we have our event data, which we will send together with the TM51 telemetry. And then we will have transmission buffer, where we will store our byte stream that we will send over. Then we initialize the server, but that's for the demo purposes only. And then we will initialize the PUSopen stack, one function that we call for sending TM51 over. We will generate a byte stream here, take that byte stream which we have in the buffer, and we know the length of the byte stream. We will feed it into whatever you want in your application, into the radio or data bus, and then we just close the server and close the main function. So that's about it for the sending side. Now let's have a look at the receiving side. So again, we will start by including the header files, and we actually only need one, the PUSopen.h. As we said, we have a main function here, and again we will initialize the PUSopen stack in the layers. In this case, we will initialize one more layer, which is PUSuser, and that's the layer which is actually processing received telemetry packets. And I will show that to you in a second. We will open the socket to the server, and then we will, since this is the receiving side, we will actually wait in the loop for the data coming from the server. Once the data are received, we will feed them into the PUSopen stack, and then we will trigger the stack to process the received byte stream. The stack will recognize the frames and the packets in the byte stream, and will trigger the reception function, which we will define then separately in a second. So here is the main loop. As I said, we are receiving data from the client, so that will be, in your case, that might be a reception function from the data bus or from the radio. Then we call one function here to feed the received data, the byte stream, whatever that is, into the PUSopen stack. PUSopen stack will then recognize the packets in the byte stream, and we will trigger, once that will happen, we will trigger the PUSopen stack to receive, to recognize the CCSDS packets inside, and then indeed the TM51 inside. And we will just close the function, the main function here, and here we will define the reception function, which is the hook function, which is called by the PUSopen whenever the full packet is received. And we have the stop condition for the main loop in our code. The reception function for the packet in this case is very simple. We just print out the PUS service, subservice, the destination API ID, and then the sequence flags, and we also print out the payload of the packet. And that's it. That's what we do in this demo. In your application, indeed, you can define what you will do with your packets in this function. So let's now build our demo. We will call our build script, build the batch, and then we see that the build process went okay. We are actually translating the configuration file for the client, where we are enabling the PUS service 5. We are translating also the configuration file for the server, and then we are building the client and the server applications, and that went okay. So let's now run the demo applications. Here we go. We will first trigger server, and the server is now waiting for client to connect so it can send the TM51. So we will run client application exe. We will just say that we should connect to the local address, and here we can see what happened. So once the client connected to the server sent over TM51, and our custom hook function then printed out that we have received TM51 destination API ID 3, which is the API ID of our client here, and then our test data 1, 2, 3, and 4. So this is how you can send PUS5 telemetry messages with PUSopen. We want to keep it simple for you. You've seen it. It's about 10 lines of code on the sending side and 10 lines of code on the receiving side. It's simple, but it's proven. PUSopen has a space heritage. It worked flawlessly for different missions. Teams have used PUSopen on board of their satellites and as a tool for prototyping and testing their software on the ground. We provide training and we will tell you how exactly we comply to the space software and space communication standards. So thank you for watching. Visit us at PUSopen.com and do not hesitate to contact us for a quick chat. Have a great day.